Hello everyone and welcome back. In this lecture we are going to discuss DynamoDB's read and write capacity modes. Now read and write capacity modes controls how you are charged for your read and write operations that you do on your DynamoDB table or a secondary index. Now there are two read-write capacity modes that you can set while creating your table, and also you can change your capacity mode later on as your application grows. Now there are two types of capacity modes available: on-demand and provisioned. Now on-demand capacity mode is truly a serverless mode of DynamoDB. So in this mode you are billed for the exact amount of data reads and writes that you do for your table, and you don't have to provision any upfront number when you are creating your table. So it's a pay what you use model, and you will be charged for the amount of resources that you utilize. So let's say your application has an unpredictable workload and you do not know beforehand that when the spikes of traffic would occur, or the traffic varies a lot, then this is the mode that you should go with. The other mode is provisioned. In this mode you need to define your read and write capacity units or throughput that you expect your application to consume. So this is the mode to go with in cases when you have an idea of how your application traffic is going to behave beforehand. So an ideal way to set up your capacity mode is to start with on-demand mode, and as your application grows and you have an idea of how the traffic behaves throughout the day or over a period of time, then you can switch to provisioned mode. So when we create a DynamoDB table, the default mode is on-demand mode, and auto scaling option is enabled by default. Now both these read and write throughput defined in units. So you need to define both read capacity units or RCUs, or write capacity units called WCUs, in provisioned mode. Now one RCU is nothing but one strongly consistent read per second of maximum 4 KB of item. So let's say you have a JSON of 4 KB and you do one read, one strongly consistent read every second, then you will consume 1 RCU of throughput. Now 1 RCU is also equal to 2 eventual consistent read per second with the same size of data, which is 4 KB. So strongly consistent read consumes more RCUs than eventually consistent read, which makes sense because strongly consistent read consumes more resources in the background to get the latest data from the table. Now RCUs consumption are proportional to the amount of reads per second and the size of items. So if your item doubles in size, let's say 8 KB, and you do a 1 strongly consistent read per second, then you will consume 2 RCUs. Now in case of writing an item to table, for obvious reasons it takes more resources because you're writing something and then there will be indexing done for that particular item. Because you're writing to a table, DynamoDB is going to consume more resources in the background. So in case of WCUs, you would consume 1 WCU to request 1 write operation for 1 KB of item. And in case of transactional writes, you will consume 2 WCUs for 1 request. Again, consumption of RCUs and WCUs are proportional to size of data. So if we double the size from 1 KB to 2 KB for an item, your write capacity unit consumption will double up as well. So this is a very basic calculation that you will have to do to estimate the number of RCUs or read capacity units and WCUs you need to set in provisioned mode. And following the same calculation, you can estimate your bills as well. Now when you create a DynamoDB, you need to define your keys and throughput, right? So this is a simple example using AWS CLI, how you can define your attributes and then your key schema, which is nothing but defining your primary key and sort keys, and then your provision throughput. You can define your read capacity units and write capacity units. So this is how you can create a DynamoDB in command line mode. We obviously are going to create it in serverless YAML, but to give you a basic idea of how you set your attribute names and key schema, you will have to provide the create table command, then the table name. Here we have orders, then we define the attributes. You need to define at least those attributes that you want to project in your queries, or the attributes that you are defining as primary key or sort key. So in the first case, here you can see we just have one primary key, which is order ID in the orders table. So we have defined order ID as attribute name, and then the type is string, and then we define our key schema. So here we just have one primary key, so we are defining order ID as our primary key. To define a primary key, you need to give key type as hash, and then we are defining our provision throughput as read capacity units and write capacity units. Now in case we want to define our primary key and sort key in our key schema, then we obviously have to define both these keys that we plan to set as attributes. So here, along with order ID, we also have defined user ID, and under our key schema we have again defined order ID as our primary key, and to define our sort key we have defined user ID as type range. So sort keys have the key type as range, and primary key as key type of hash, and again we have defined some provision throughput. Now as I mentioned earlier, on demand is a flexible billing option. You don't have to do any capacity pre-planning while creating your table. DynamoDB scales and throttles as per your load. This is good for unpredictable application traffic. One thing to note here is the request rate is limited by default table quotas that AWS sets for a table, and there's a table available here that defines these quotas that you can expect your table to scale to by default. Obviously you can increase these quotas by requesting AWS, but by default per table you can do maximum of 40,000 read request units and 40,000 write request units in on-demand mode. And in provision mode we have quotas at the table account and for global secondary indexes. So for table we have 40,000 as a limit for RCUs and WCUs in provision mode, 80,000 RCUs and 80,000 WCUs per account in provisioned mode, and the minimum throughput that you need to set for a table or global secondary index is 1 RCU and 1 WCU. In provision throughput, you need to predefine your RCUs and WCUs that you expect your application to consume. Some level of auto scaling that happens in provision throughput mode as well, so DynamoDB do not immediately reduces the resources as your load goes down. It keeps your RCUs and WCUs available for some extra time, for a few extra minutes, even if the load goes down, in order to decrease flapping. Obviously provision throughput gives you more predictable cost for your application, so even if the load goes higher than your RCUs and WCUs throughput limits, you won't be charged extra. Your performance might degrade a little bit, but you will not be charged any extra cost more than what you have set as your throughput. Now provision throughput is also ideal for applications which have consistent traffic and ramps up and ramps down gradually. Important thing to note here is that if you have global secondary indexes, you need to set auto scaling separately for them from your base table. So your base table and your GSIs will have separate provision throughput. Now, as I mentioned earlier, we are going to create our DynamoDB table using our serverless YAML file. So instead of using the AWS CLI, here is an example of how you can create a DynamoDB table called orders table in your serverless YAML. So here we have just defined our type of resource as DynamoDB table, and then you need to define at least those attributes that you plan to use as a primary index or secondary index, either as your table index, base table index, or in global secondary indexes. So here I have defined order ID, user ID, amount, and created at 4 attributes under attribute definitions. Then I have defined my base table key schema, which is nothing but defining my base table's primary key and sort key. So here I've defined order ID as primary key because the key type is hash here, and order ID is my range. Now billing mode is set as pay per request or on demand by default, but here I have set my billing mode as provisioned. Now as soon as I set my mode as provisioned, I need to define provision throughput, my RCUs and write capacity units. So here I have defined my RCUs as 5 and write capacity units as 10. I have also defined my global secondary index here. Now as this is a global secondary index, it kind of acts in the background as a separate table from my base table. When DynamoDB indexes my GSI, here in this case the name is user ID index, it will kind of create a separate storage space in the background, assign separate partition keys and resources. So I need to define key schema. Here I have defined my primary key as user ID because user ID is hash, and I've defined amount as my range. Now in this case, I also want to project all the other attributes that are in my item. So I have defined projection type as all. So if I query my global secondary index, user ID index here, using my primary key as user ID and sort key as amount, so I can query for a particular user ID and get list of items with having an amount in a particular range or equal to a certain amount. And I also want to project other attributes which are order ID and created at, right? So this global secondary index allows me to do that because I have defined projection type as all. So when it creates this index along with the primary key and sort key, it will also index created at and order ID attributes. I have defined another local secondary index just to give an example of how you can. So this is the default index, the first one. Along with that, on the base table, I have defined another local secondary index, right? So let's say I want to set my primary key as order ID and I want to set my sort key as created at, right? So I can use this index created at local secondary index to fetch all the order IDs by defining my range as created at, right? So I can get order IDs created between 2 dates or order ID created at a certain timestamp. Now here in projection, I have defined just one non-key attribute, which is amount, and the type is including, right? So when this local secondary index gets created, the index will have the key schema attributes, order ID and created at. Along with these two, the index will also save or index the amount non-key attribute, right? If I set it to exclude as projection type, it will pick all the other non-key attributes except amount. So this is a basic example of how you can create a DynamoDB table and set different indexes and set your billing mode and read and write capacity units. That's all for this lecture, and I will see you in the next one.